Hello there, lads. This is Amatoa, and yeah, this is sort of like a more informal video. As you can see, it is well past my bedtime. I got like went down a rabbit hole with there's like these guys Zeta Scale that are making like um this new like sort of computer, and saw it and I was like, oh, this is probably a grift. But then like I went on their GitHub and it was like, ooh, there's a paper here, and then from there it was like their light paper, and it's actually really interesting. Like um, they sort of break up. Uh, I mean like they break up these models into like univariate functions. So if you imagine if I have a function, f, that is a really bad f of x comma y, what they want to do is instead of running f of x comma y, they run like g of x composed by h of y. And there's like this theorem uh here. Um Kolmogorov Arnold's representation theorem that like all um, multivariate functions can be pretty much represented as univariate functions. So what I'm gonna do is like basically walk through on this, not piece of paper, like digital piece of paper, running a linear regression in like an Exa style path. So if for I have like ChatGPT up on the screen here. It's the one walking me through. So for inputs x1 comma dot 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 comma x n, we are computing y equals the sum uh I equals 1 to n w I x I plus b. So for this tiny example, we're going to use n equals 4. So this is actually like the simplest case, basically, because there's only one variable, but I don't know, it'll be cool. So let's inputs. So 1, 2, 3, 4, x1, x1. So okay, that is actually like, terrible. Oh, there's like a square tool built in. There, there, um, there, and there. And then turn this off. So this is x1, x2, x3, x4. And then let's write, I don't know, example numbers 2, -1, 0.5, and 3. So next, we're going to, so in the paper, they have like sections 2 and 3 that basically here. So, introduction and stuff, they talk about, blah, blah, blah. Current hardware solutions can't adapt to different AI architectures, blah, blah, blah. They suck, blah, blah, blah. We made like a better computer. And their approach is basically like, here, I'm just like reading from the paper as I'm talking. Um, Maybe it would be better if I like split screen. There, there. Okay, now you can see it. So, learnable function units. So any univariate function R to R. So in our case, these are going to be um multiply. So here. In hardware, each LFU uses specialized components designed to simulate any univariate function with high fidelity. The function implemented by an LFU is pre-configured as a hyperparameter, adjustable parameters for fine-tuning, or just training. Um, Two additional operations. Uh, Interesting. Okay, here, complex interconnected system, cool. And then this is like Exa-completeness. It's kind of funny now because they changed their name to Zeta Scale. Um, so really it should be Zeta completeness. Okay. Isomorphic. What does this word mean? What does this word mean? Two things have the same structure. Um, let A be a set isomorphic to R or a computational approximation thereof. Okay. Define a system S. Okay, apparently isomorphic just means like um there two things have the same structure even if they look different. Okay. Define a system S equals open parentheses BTP. B is a finite set of basis functions. I think that's like omega. Ooh, Euler phi function. Nope, it's phi. Cool. T is a finite set of transformation functions. B to B is a finite B to A to A. I do not understand this. Take screenshots. Copy. Explain each of these requirements to me. This to me. Okay. Um, So, okay, um, B is basically, I guess it says it right there, it's a finite set of basis functions. So, like, B is equal to phi 1, phi 2, and then 2, phi n, close. So, like, and these phis are just, functions. So, I don't know, phi 1 of x is equal to x squared, phi 2 of x is equal to ax plus b, where these two are constants, etc. Um, okay, T is a finite set of transformation functions. Um, hmm. Okay, so this notation right here, B arrow, that is a terrible error. B to A to A. You may notice this right here, this right here are the same. So what this is really saying is that T is a function that maps one of these functions B to another function. So um, if so over here, like we have phi 2 of x is equal to um, ax plus b, maybe then uh, t phi uh, t phi 2 of x is equal to 3.7 x plus 2. Um, polymorphism. So this is basically like you can configure um, you can basically like configure the functions. Um, poly polymorphism. They use that word a lot in their marketing and stuff. Um, and then finally, P is a finite set of superposition methods. Now, when I heard of superposition, I thought of like, quantum whatever, Schrodinger's cat. Basically, uh, hmm, so P is a function that takes, this implies a list, or this, I suppose, means a list, or uh, sequence. These are a bunch of functions, and then it maps it to a new function. So, for example, p phi 1 comma phi 2 could be composition, so that would be phi 2, phi 1, x. This is, hmm, there could be addition, so phi, I missed, phi 1 of x plus phi 2 of x, could be, uh, yeah, the system S is let epsilon greater than or equal to 0, representing the desired approximation error for the system. Because I think because you're decomposing, I suppose recomposing, um, there is some error basically. That is a very scary looking um sequence. Explain what all of these scary symbols mean. Way I can sketch out in a journal. Okay. Um, universal quantification. Okay. So for all, okay, so for all f in C, what is C? Um, okay, CAA is the set of all continuous functions from A to A. C A to AM to AN is the set of all continuous functions. Okay, so for every function in the set of all functions, so this comes to just for all functions. What does this symbol mean? Existential. There exists, or there is at least one H in H dot sup. Here, there exists a function lowercase h in capital H. Uh, for all function h in capital H. So this means supremum, the maximum value of f of x minus h of x is less than or equal to epsilon, where H is the set of all functions that can be constructed using finite compositions of elements from B, T, and P. So that is a bunch of um, jargon, but basically what this is saying is that there is some function that we can construct using our previously defined functions that comes within a certain that is under a certain amount of error. Sorry. For so what this is saying is for every function we might want to emulate, there is another function that we can uh, create through composing our our earlier functions that comes within a certain error of the function we want to approximate. And then this is that's the natural numbers. Holy smokes. Explain this. Okay, so um for all mn in the natural numbers, so that's like all positive non-decimal numbers basically. They're for all here. So for all functions, for all natural numbers mn, for all functions f in c a to am to an, there exists a function g in g. G is the set of all functions an to an that constructed using finite combinations of functions satisfying condition 1, where the error is less than or equal to epsilon. That's why it's called extension. So this thing is pretty much saying the same thing this thing is, except with multiple variables. In the context of our polymorphic computing system, the LFU set of basis functions B corresponds to the initial configurations of our LFUs, while the transformation functions T represent the reconfiguration capabilities of these units. The superposition methods P are realized through the interconnections and compositions of multiple LFUs. Cool. Um, yeah. Uh, I hope that was interesting. It was interesting for me at least. Goodbye.